Okay, welcome to the notes, examples and practice questions for binomial expansion year 2. So this is expanding on your knowledge of binomial expansion for year 1. Now, this is going to cover negative or fractional indices. Notes start with for a plus b to the n, if n is negative or fractional, you can use the expansion which is given, which is here. So we'll use the expansion later on and we'll explain kind of what it all means. But basically, if you've got 1 plus x to the something, you have 1 plus n to the x, and then n times n minus 1 over 2 factorial, so 2 times 1. And then whatever the x term is, squared. Then n minus 1, n minus 2 over 3 factorial, and whatever the x term is, cubed, and so on. Now, the expansion is only valid when the x component of the function is less than 1, and that is what means we can ignore all of these terms which are x4, x5, x6, because if x is less than 1, as you increase the power, the value of x to the 4, 5, 6 reduces, so therefore can be ignored. Now the blue box is really important today. The formula must be in the form 1 here. So we can have something on the outside, but it has to be a 1 there. So you will need to factorise out any numerical constant. And we will look at that in the examples. So if we make a start on the example, I'll leave that formula on the screen up there. So find the first 4 terms of 1 plus 2x to the half, and then stating the range of values for which the function is valid. So to start with, I'm going to do the expansion. Now the first thing we have to do is check that that is a 1, and then we have a fractional power, so we need this new expansion. So we start with 1, then we have nx, and the x term in this case, the x term is plus 2x. So n is the power from here, so n is the power, and then we have 2x. Then we have n minus 1 over 2 factorial. So n minus 1 over 2 factorial, so that's 2 times 1. And then we have all of the x component squared. And then half minus 1, half minus 2 over 3 times 2 times 1 and 2x cubed. And now what we need to do is simplify, and the easiest way of doing this is to put the whole thing in your calculator. So the first term is going to be 1. This one is fairly straightforward, so half times 2 is 1x. But then what we're going to do is put everything in our calculator. So on the top you want half minus 1 over 2 times 1, and then you want times 2 squared. So you need all of that information there. So all of that goes in my calculator, and that gives me minus a half, and then I have x squared. And then the same for the fourth term. So all of this in our calculator, we can actually just go in and add the things, and then 2 cubed. And that gives me plus a half x cubed. So that is my expansion. We're substituting into the formula very carefully, and then we are using our calculator to simplify, not trying to do that in our heads or anything like that. Okay, now, the final part of this question is state the range of values for which the function is valid. Now it said here we need all of the x component to be less than 1. Now the x component here is 2x, so therefore the x component is less than a half. Now that is the equivalent of this, because it's saying that x, the distance of x has to be less than half, so it can be from minus a half up to 0 as well. So that is my validity, and we're going to think about that every time. Okay, question 2. Find the first 3 terms in the expansion of this, and then in yellow later on we're going to use this to approximate this. Okay, so n is minus 5 and the x term is minus 1. That's a 1, so we can proceed without having to worry. So what that gives us is 1 plus n x, and remember the x term is minus x, plus n minus 1, 2 times 1 x squared, plus n minus 1, n minus 2. And what I'm actually going to do here is I'm just going to add in this 1 minus x to the minus 5. And that's really important for year 2 binomial, which we'll see later on. So what we are going to do here is we're going to simplify. I'm going to put all of that in my calculator. So that is going to give me 1 minus x to the minus 5 equals 1 plus 5x plus 15 x squared plus 35x cubed. And that is my expansion. Now it's asking me to use x equals 1 to approximate that there. So what I'm going to do is I'm going to sub x into both sides of the equation. And this is really important because this side, the left-hand side, won't always give you exactly what you're asked for. So we are hoping to approximate this. So if we sub this in, I have 1 minus 0.1 to the minus 5. And I'm going to sub that in on this side as well. Now 1 minus 0.1 is 0.9. So 0.9 to the minus 5. And that equals 1.685. And what that means is, that this is my correct answer, because this is the same as 1 over 0.9 to the 5. So that's fine, and it equals 1.685. And actually I'm going to check that's a sensible answer by just putting this in my calculator. So 1 over 0.9 to the 5 equals 1.6935. So that tells me that that's a sensible answer, and it's probably correct. The reason that we have to sub into both sides is sometimes it could be the case that actually once you substitute into the left-hand side, so into this bit, it might give you something like 2 over 0.9 to the 5. In which case, to actually approximate this, you would have to divide the whole thing by 2. Now, we didn't have to do that in this example, but in one of the practice questions you will have to. So it's just crucial that we always sub into both sides of this expansion. That's one of the most common mistakes for binomial, particularly in the year 2 expansion. Okay, question 3. Got a clue here. By first factorising by 4, find the first 4 terms in the expansion of this. Now first we're going to have to make that a fractional power. So this equals 4 plus x to the half. But what we have to remember is this is only allowed, we can only use this expansion if that's 1, which it isn't currently. So 4 plus x is the same as 4 1 plus a quarter x. But given all of this is to the power of a half, that means all of this is to the power of a half as well. Which means we need to apply the half to the 4 and to the bracket. So we have 4 to the half and 1 plus a quarter x to the half. So that is 2, 1 plus a quarter x to the half. So that is the first stage of this, to make this something which is legally allowed to be expanded using this expansion. And now what I've got is I've got a 2 that's going to go on the outside, and then I'm expanding. So 1 plus n x plus n minus 1 x squared, and it's the first 4 terms. Sometimes it asks for 3 or 5. Okay, I'm going to leave the 2 there and I'm going to expand. This one's easy enough. And then I'm going to start putting in my calculator. So I've got all of that there, all of this, and a quarter squared. Here I'm going to have all of that, and a quarter cubed. So it's minus 1 over 128 x squared, and 1 over 1024 x cubed. And then finally I can expand, so 2 plus a quarter x minus 1 over 64 x squared plus 1 over 512 x cubed. And that is my expansion. Now if I were asked for the validity, this is the expansion component, so it is a quarter x is less than 1, so x is less than 4. And that ensures that when I do x cubed and x to the 4 and x to the 5 and x to the 6, it's less than 1. So therefore, as I raise the power, the value becomes smaller. So summary. We are carefully substituting into the formula that is given. So the formula is given, and we must just carefully substitute in and use calculator to evaluate. Validity involves the x component of the expansion. So whatever I expanded, I use. So if it is minus x, then that is the same as x is less than 1. Or if it was 4x, then that's x is less than a quarter. So validity is often important. And then when approximating, this is the crucial bit. When you are approximating, you must sub into both sides of the equation, of the expansion in fact. To find the value you are asked for. And you can always check on your calculator for approximations, which we'll see in the practice questions as well. So that's your box. Write that down, make it clear, put some colour around it, make it obvious so you can come back to it if you need it. And then we're going to move on to the practice. Okay, practice questions. Try these on your own, try them somewhere different to your notes, and then if you need the answers, they're going to be here and they're going to be on the website as well, www.stutchfield.com. Okay, first 4 terms of this, I've got a 1, good, stating the range of values for which the function is valid. So I've got a 1, that's fine. So 1 plus n x plus n minus 1 So we're just subbing into this carefully, and then when I come to evaluate, I'm going to put in all of these bits in my calculator. So minus half squared, all of that, minus half cubed. So putting that all in my calculator, don't forget about your x squareds and your x cubeds, and then that is my expansion. Now the validity is what we've done for the expansion, so we expanded this, so minus x over 2 is less than 1. So the minus sign we can remove because it's a modulus, so x has to be less than 2. and that is your validity there. Okay, B. The expansion of this up to the x cubed term is given to you here. By using the substitution x equals this, find a decimal approximation to root 2, checking your answer. Okay, so remember when we're approximating we have to sub into both sides. So on this side, 1 minus 2 of that equals 1 minus x squared over 2 minus x cubed over 2. And I'm actually going to store 0.01 for x. So on the left hand side, 1 minus 2x equals 7 root 2 over 10. And the right hand side, 1 minus x minus half x squared minus half x cubed. Okay, so this is where your subbing into both sides comes in really, really important. If we were to check root 2 is what we're aiming for. We're aiming for something that is approximately 1.4142 something, which this is not currently. But the reason for that is because I only want root 2. I don't want 7 root 2 over 10. So what I need to do is I need to divide both sides by 7 over 10. And that will leave me with root 2 equals, I can go back up to the answer I had and divide it by 7/10, and that equals 1.414213 something. So therefore root 2 is approximately 1.4142. I'm going to leave lots of decimal places for this because it's binomial expansion, and when we're talking about numbers like this, we need to make sure that we're looking at those decimal places. And I've checked my answer because I'm aiming for something like that. I can use my calculator to tell me what I should be expecting. So subbed into both sides and therefore got my answer. Okay, question C. The first three terms of this expansion are 3 plus all of this. Okay, this is a challenging stretch question here. Now, the first thing I need to do is I need to write this as a fractional or negative power. Now that's going to be a plus bx to the power of minus a half. But remember, we can't use the expansion unless this is a 1 here. So I can't assume that a is 1. So what I need to do is I need to factorise out a. So that's going to become 1. But this is actually going to become b over a x. And that's all to the minus half. So we have a to the minus half, 1 plus to the minus half. So that's what we're expanding. And we're going to expand and we're going to look up to the x squared term to compare our coefficients. So we have a to the minus half, 1 plus n x plus n minus 1 b over a x squared. So a to the minus half, 1. This is minus b over 2ax. I'm going to put that on my calculator. So this is 3/8. And then I've got b squared, a squared, x squared. And now I'm going to expand it further to get my values. But I'm actually not going to simplify it just yet. So this is going to be minus b a to the minus half over and plus 3b squared a to the minus half Now the reason I'm not doing that just yet is because I don't want to need to worry about making a mistake while doing that simplifying at the same time. Because what we're actually going to do is we're going to find the value of a. So this is the numerical term. So that means a to the minus half equals 3. Now on your calculator you can do a root to the power of n where you can put in minus half. So 3 and you're rooting to the minus half. So a equals 1 over 9. That's your first answer. Now looking at your second term here, we have a third x is equal to this. So minus b, but now I know what that is. I actually know a to the minus half from here is that a to the minus half. So I can actually put a 3 in there for that, and that's over 2, and a is a ninth equals a third. And then I can simplify what that b is there. So I've got minus 3b over 2 ninths equals a third. So b equals, and I'm going to do a third divided by, and I'm actually just going to put in all of this, just like that. So it's divided by minus 3 over 2 divided by 9. So b gives me minus 2 over 81. And they are actually my two answers for a and b. Now, what I'm going to do is I'm going to use the third term just to check this here. So I'm going to store 1/9 for a. So 1/9 in for a, and minus 2 over 81 in for b. And then I'm going to put all of this in my calculator. So fraction 3b squared a to the minus half over 8a squared gives me 1 over 18, which is there. So they look like they're probably correct. So that's a really tricky question there at the end. That's a real stretch, and it's testing your understanding of the fact that you can only expand it if it's a 1 here, but also just testing your algebra, just testing that you can follow through stage by stage and be really diligent and not make mistakes. So if you got that one, really well done.